This video is going to cover how to simplify exponent expressions when I have to combine more than one rule. So let's go ahead and get started. As soon as I look at a problem that has exponents and I see a multiplication sign or something for me to simplify, I'm going to try and remember a few of my rules. I have the product rule, which means I add exponents if I am multiplying. I use the quotient rule if I have division, and I use the power rule if I have parentheses and an exponent outside. Now as I see this problem, I have some fractions going on, and I also have multiplication going on. So we're not going to worry about the power rule, but the product and the quotient. To get started, I'm going to multiply my two fractions together. And I'm just going to combine into one big fraction. Notice I have two a's on the top, two terms with an a on top. I'm going to group those together. So I have a to the fifth power, a to the second power, b to the third power. I'm going to rewrite this with a better marker. A to the second power, b to the third power, and c to the ninth power. Now I have included each one of those factors. So I'm going to make the bottom part of my fraction, and I'm going to multiply those together. So rewriting that, c to the fourth power and b to the eighth power. As soon as I have one big fraction, I am going to first use the product rule to simplify, and I'm going to focus on one part of the fraction at a time. So I'm just going to focus on the top part to see if there's anything I can simplify. As I look at the top part of the fraction, they're all different except for these first two terms. If these first two factors, if these first two factors are the same, I should be able to combine them. Remember, this is just the same as writing a times a times a times a times a, that's 5 a's, times a times a. 5 for the first a and 2 for the second. So if I combine them all together, that means I have a to the seventh power. Or remember, I can just add my two exponents, 5 plus 2. Now as I look at b and c, I could write those all separate, b times b times b, and c times c, and there's a lot of c's. There's nothing to combine with those, so I'm just going to rewrite them on top. b, 3, and c to the ninth. I'm going to go to the bottom part of my fraction, and I'm going to simplify anything in the denominator. Well, I have 4 c's and 8 b's, but there's nothing to combine there, so I'm going to rewrite that. Now, my next goal of my problem is to simplify and cross out any similar factors on top and on bottom. Now, I notice I'm going to rewrite a new fraction bar to go where my answer is going to go. And I notice that a only appears on top. So I don't have to simplify it with anything in the denominator, and I'm just going to rewrite it. Now I do notice that there's b's on top and on bottom. Remember, b3 is b times b times b, and b to the 8th is b times b times b times b. That's 4, 5, 6, 7, 8. Remember, when I have the same factor on top and bottom, if they're similar, I can cross them out. So 1b cancels with 1b on the top and bottom, b cancels with b, b cancels with b. Notice I have no b's remaining in top, so I'm not going to rewrite a b on the top, but I do have b's remaining in the bottom, so I am going to write b in the bottom. And there's 1, 2, 3, 4, 5. Remember my quotient rule, if I have the same letter in top and bottom, I look to see where there's more in the denominator, and I can put b in the denominator, and remember, you can subtract your exponents. 8 minus 3 is 5. Now as I look at c's, c to the ninth, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's 4 on bottom. Remember, if I use my rule, there are more c's in the top, so c is going to go with the top. 9 minus 4 is 5. Let's see if our rule worked out. 2, 2, 3, 3, 4, 4, and I have left 1, 2, 3, 4, 5. And that would be my simplified expression. A to the 7th, C to the 5th, divided by B to the 5th. All right, let's go ahead and try another one. So I have G, G to the 2nd power, H to the 4th, divided by M, times M to the 3rd, B to the 2nd, G to the 2nd, and H to the 3rd. So let's go ahead and combine our fractions. That's what we've got to do, combine them all to begin with. So G squared, H to the 4th, M to the 3rd, B to the 2nd, and then the denominator M, G to the 2nd, and H to the 3rd. Now remember, we're going to look at each side of the fraction separately. So as I look at the top, I notice that they're all different. So I don't need to worry about combining anything on this problem. And as I look at the denominator, I also notice that they are all different. So I don't need to worry about simplifying anything. So I'm going to go my second step and determining if I can cross out anything on the top and the bottom. So here we go. I'm going to start with G's. All right, G squared. Well, I have G's on top. Here's one, and G's on bottom. Now, if you notice that they're the same, G squared and G squared. Now, if I use my quotient rule, normally we look for which one is bigger, and neither one is. If I subtract 2 minus 2, you notice that I get 0. That means all of the G's eliminate. Notice what happens if I write it out. G times G and G times G. They cancel each other out, and there's no G's remaining. So G's are marked off the map, gone. All right, let's look at H's next. So I have H's on top and an H on bottom. So as I simplify, there's 4 on top, 3 on bottom. That means there's more remaining on top. I'm going to write H's on top. How many more remaining? 4 and 3. 4 minus 3 is 1. If I write it out, you'll see the same thing. All right, let's go ahead and look at M's. So M's. Now on top I have 3. On bottom, it's not clear. It doesn't say. If there's never 1 written, there's automatically a 1, and I want you to write that in. As I look at my rule, there's more on top, so M's remain on the top. And I'm going to cross out, if I have 3 up top, 1 on bottom, 3 minus 1 is 2. So I look for B's. Oh, M's next. Oh, yeah, we're good with M's. Got those. If I look at the B's next, I notice that I only have B squared. Now, you'll notice that I don't have anything left in the denominator. All the H's canceled out, all the M's canceled out. So what do? Technically, there's an imaginary 1 in the denominator, but we don't write that out. We just, when we simplify, I write H. You don't need to include the exponent of 1. That's simplified. M to the 2nd and B to the 2nd. And that would be my final simplified answer. All right, we're going to look at 2 more examples and then give you a chance to practice. So example number 3. Now this is different than my other 2 examples. I have parentheses with an exponent on the side. That means this is the power rule. And what I'm going to do is I'm going to repeat everything in these parentheses 3 times. 2a squared b to the 5th, that's once. 2a squared b to the 5th times 2a squared b to the 5th. Now I repeated that 3 times. Now I'm going to write 2b to the 3rd because I got to include this last part right here. Now notice what happens if I were to combine all 3 of these things, and I'm going to reorder it 2 times 2 times 2, a squared, a squared, a squared, b to the 5th, b to the 5th, b to the 5th. And if I were to combine these, I'd have 2 to the 3rd power, a to the 6th power, and b to the 15th power. 2 plus 2 plus 2 is 6, 5 plus 5 plus 5 is 15. Remember how the power rule is. everything gets raised to the third power. 1 times 3 is 3. Oh, sorry about that. 3 times 1 is 3. 2 times 3 is 6. 5 times 3 is 15. So notice in my work, there's 3 2's, there's 6 A's if I add up 2 plus 2 plus 2, and there's 15 B's if I add 5 plus 5 plus 5. Now don't forget that I have this tacked on the end, so times 2b to the third power, so let's include that. Well, there's another 2, so I have 2 to the fourth power, times, there's no extra a's, a to the sixth power, and b. Now don't multiply your exponents because I don't have these parentheses. 15 and 3 b's make 18 b's. Now one thing that you can do is simplify. I can calculate what 2 to the fourth power is. 2 times 2 times 2 times 2 is 16. A to the sixth power, b to the 18th power. And that is my final answer. Alright, last example. Now let's look similar to the first two problems, except I am incorporating some numbers. So let's see how that changes things. So again, I'm going to multiply, and I'm going to leave my terms separate. So 3 times 14 times a5, b to the second, and c to the 8. Notice I wrote the two numbers up front, and then I included all my variables. Now let's look at the denominator. 7 times c to the 9th, a to the 3rd, and b to the 5th. What we're doing is we're looking for common factors. Now, 3 doesn't have any common factors in the denominator, so in my new fraction, 3 is going to stay. 14, it doesn't have any other common factors, but always split your numbers into the smallest they can go. 3 can't be split any smaller, so I don't need to worry about that. But 14 can be split into 2 times 7. So 14 is really 2 times 7. Notice 7 is also in the denominator. That means I get to, if I have the same factor on top and bottom, I get to cross it off. Now what's remaining in the top, what didn't get crossed out, is that 2. So 3 times 2. Now let's look at A's. I have 5 A's on top, 1, 2, 3, 4, 5, 3 on bottom. Okay, what happens? Remember my rule, more A's on top. How many more? If I cross them out, 3, 3, there's 2 remaining. Okay, you want to start getting the practice of just subtracting these. So that takes care of the A's. Now let's move on to the B's. I have 2 on top and 5 on bottom. Okay, the 2 on the top cancel out, 2 of the bottom cancel out, more B's remaining in the denominator, 3 more. And finally C's, there's 8 on top and 9 on bottom, and I don't want to take the time to write them out, but I noticed that there's more in the denominator, so the C's remain in my denominator. With how many extra? There's 1 extra. So as I finish my simplification, hey, make sure you pay attention to those numbers. Can that be simplified? 3 times 2? Why, yes, I know what 3 times 2 is. It's 6. 6. A to the second goes on top of my fraction. B to the 3, and C, remember when we simplify, we don't write exponents of 1. And this is my final answer. Alright, if you have any questions, please reach out. Have a great day.